Next presentation is active noise control system for automobiles.
Actually, John, my colleague raises a good point. This team should go talk RF with the wireless tablets and get to see this online. Yeah.
So hello, my name is Marco Zamora, and my team members are TJ Gong, Wolfgang Garzon, and Wesley Mize. In this project, I worked in hardware with Wolfgang, while TJ and Wesley focused on software and the algorithm. Our project is an active noise control system for automobiles, and the purpose of our project is to mitigate road noise heard by the driver in an open environment in order to improve driving quality. What this means is that if a driver uses our system in their vehicle, the driver should noticeably hear a decrease in road noise without the need of any personal equipment such as a headset, since it's going to cancel it out in an area. And what separates us from what's currently in the market is that we're using active noise control system instead of passive barriers in order to cancel out the noise. In order to do this, we implemented an LMS algorithm on a TI C6713 DSK. This LMS algorithm is an adaptive algorithm which handles the road noise and outputs the anti-noise, which is corresponding to the road noise, to cancel it out. On the hardware side, we have a DSK with our microphone inputs and our speaker outputs. These microphones and speakers are selected based on their ability to handle road noise below 1 kHz, which we selected based on the ability of what the user can hear, where the road noise is majority located at, and will get canceled out. Next on the slide, we have our diagram, our design schematic. On the left side, we have the input microphone. This input microphone handles the raw noise and takes it to the board. And as seen on the diagram below, it's placed farther away from the driver compared to the other hardware, like the speakers or the mics, other speakers and microphones. Next, we have the speakers. These speakers output the anti-noise and to cancel it out, and they're located on the headrest towards the driver's ears. And finally, we have our air microphone. This air microphone is the focal point of where the road noise and the antennas are going to meet. And it creates a small zone around it of where the road noise is actually mitigated. And due to this, we have to place the air microphone really close to the driver's ears, so the driver also gets a similar effect. Now, first semester, we focused on getting familiar with the DSK and also figuring out what algorithms we're going to use, and we made simple filters in like C++ using Code Composer. This semester, we focused on getting familiar with implementing the LMS algorithm onto the DSK, and we also moved from Code Composer to Simulink, because it allowed us to implement our hardware and test it without the board itself, and also put our code on the board. But this also gave us a bit of issues, due to the fact that when we tested everything, all the equipment separately, it worked fine. But we put it together, the LMS, the board decided to do some mathematical errors, which I guess due to memory mapping decided to not give us the correct output. And we wish to fully fix what there's to improve is making the LMS algorithm more stable. Because at the moment, the way it works, it likes to blow up. You can tell it's in our simulations and our testing, you can tell that it's trying to adapt, but it just doesn't adapt as well as we wish it did. We also have to make it more compact. Since this is a system that we have to implement into cars, we wish it would be smaller so we can actually implement it, but at the moment, due to amplifiers that we have and other equipment, it's much larger than we initially expected. Any questions?
Have you looked at are there any commercial systems? Did you research any, or is there anything available like this out there? Some car manufacturers that are doing it.
Yes, we researched and we found out some car manufacturers have specific frequencies they want to cancel out that are usually related to the motor and motor noise. What we're focusing on is road noise, which is the contact of the tires with the road, which usually, like when you're driving on a highway, you can easily tell you hear the road, and that's what we're focusing on, since that's intended to be below 1K, and you can actually hear that.
What happens if you've got your stereo turned on?
Usually that would be a higher frequency, and it won't go through the algorithm. And so we shouldn't hear any change in that.
What frequency are you trying to cancel?
500 to 1K. Yes. I mean, 500 hertz.
So 1,000.
Yeah.
So 1,000.
Yeah, below 1,000 hertz.
I'm not sure what you listen to on the radio, but 20 to 20K hertz is kind of, your range is in there. So most things that come up on the radio, usually when you're going to see overlap. I'm just wondering what's going to happen just recommend to cancel out part of that too. Just curious.
I'm actually curious if 1K is going to cancel road noise at all.
Yeah,
So that's, road noise is below 600 hertz.
Yes.
Toyota and Honda both use that frequency as a cutoff. So when you're talking about Honda or Toyota, the only stuff that goes through your cell phones is well, 500.
Yes. Well, we realized that, but we realized what we actually canceled out, and so we lowered it to 1K, and we hope to prove that we can actually cancel that noise out. But we can get all the road noise, as you say, because it's a bigger spectrum than we can actually handle.
Any safety considerations for the driver? I mean, if this algorithm blows up on the road and the speaker goes in the feedback, are you, is there a way to turn it off? Is there a mechanism?
We haven't worked to that part yet, since we're still trying to fix the actual blowing up part. But ideally, yes, I should have a system that will just reset the whole filter and it'll start over the beginning.
One other thing, when you block diagram, you're showing both 12 volt and 5 volt power supplies.
Yes.
Did you implement DC to DC to give you the 5 volts, or did you just go that hooked up to a bench power supply?
Ideally, work my car.
I know, that's why I'm asking the question.
We had originally planned to run it off of like a cigarette lighter, which happened to the battery was on, and we were just using an adapter to have 12 volts for the board and 5 volts, or 12 volts for the amplifiers and 5 volts for the board.
So I guess you guys are, you're all heating majors, well,
Yes.
3 of you are.
Yes.
So you get to the end of 2 semesters of senior design, and you didn't even implement the 12 volt and 5 volt DC power supply.
Well, we didn't have to because we had already implemented the elements on the computer, and we ran into the memory mapping issues in the last month, so we couldn't actually put the DSK in the car. And so by then, we were just finalizing our simulating models and making sure that the algorithm ran, rather than trying to build a easily built power supply.
You're targeting the back, if you're working on active
One of the people that helped us was come up with the design was Rizzo. These were senior design one, like advisor, and he also worked in Voice, so he helped us a bit in figuring out which algorithm would be better to use and what algorithms could possibly finalize on.